Okay, in this lesson we're going to add and subtract rational expressions. This is the first day of this. Remember, when you add and subtract a fraction, you have to get a common denominator. And so if we look at this one, we see that there is a common denominator. So this fraction would be solved. It's not really solved, it's simplified. N minus 3n minus 1. And notice that this minus is between here, so we have to put the 3n minus 1 in parentheses. And our common denominator is n minus 2. We don't add the denominator or multiply it or do anything to it. We leave it the same. And so n minus 3 minus 1 is the same as n minus 3n plus 1 over n minus 2. And so my final answer is negative 2n plus 1 over n minus 2. Okay. That one was pretty straightforward. In this one, we're going to have to get a common denominator. Our common denominator is going to be 4x squared. And so to get that, we're going to have to multiply this fraction by 2 over 2 and this one by x. So I'm going to show what we do. Multiply this by 2 over 2. That's the same as multiplying by 1, so we don't change anything. And that's a squared. And we multiply this one by x over x. And so when you multiply by 1, even though this changes form, you haven't changed the value. And so this becomes 2 over 4x squared plus 5x over 4x squared. And so with the common denominator, when we add it now, we simply have 2 plus 5x over 4x squared. Now, if you end up with a quadratic term in the numerator, you need to see if you can factor it and reduce factors, simplify it, just like you would reduce a fraction, like we did in the lesson before in 5.3. In this, we can combine these, multiply these two together to get our common denominator, which means we have to multiply the first one by x minus 2 over x minus 2. Oops. And the second one by x plus 2 over x plus 2. Okay. Then our common denominator is x plus 2 times x minus 2. Okay. We distribute the 3, so we have 3x minus 6 minus, and we distribute the 8, 8x plus 16. But remember that this negative has to distribute across here. So that's the same as 3x minus 6 minus 8x minus 16, all of that over x plus 2 times x minus 2. Combine the x's to get negative 5x, and the 16 and 6 to get negative 22, and all over our same denominator, x plus 2 times x minus 2. And that's the final answer for that addition problem. Okay? So you can always pause these recordings and go back or stop them and look and make sure you can see what's been done. Let's click and go to our next page. Okay. Wait for those to come up and get our pen. Okay. So now we have x minus 3 here. X squared minus 9 can factor as x minus 3 times x plus 3. So this has x minus 3 in its denominator. What this is missing is the x plus 3. So we can leave 8x as it is, And I'm going to write this factor as x minus 3, that's denominator, times x plus 3. Plus, I've got to multiply this fraction by x plus 3 over x plus 3, so we get our common denominator. And this will be x minus 7 over x minus 3. All right, so when we do that, we now have one denominator. Okay. And we have 8x plus, now we're going to have to multiply or FOIL x plus 3 times x minus 7. So that's going to be x squared minus 7x plus 3x minus 21 when we multiply those together. Now we're going to combine any terms that are the same. So we have x squared, and 8 minus 7x is 1x plus 3x, so that's plus 4x minus 21 over x plus 3 times x minus 3. Now here we end up with a quadratic term in our numerator, so we're going to have to check to see if we can factor that numerator. And we think of factors of 21, one's going to be plus and one's going to be minus, that will add to be 4x, multiply to be negative 21. Well, that's going to be plus 7 and minus 3. So now when we're over x plus 3 times x minus 3, we see that we have factors that can cancel, which is what we do when we reduce fractions. And so my final answer is x plus 7 over x plus 3. That's what's left uncanceled after we find the common denominator first, add them, then we factor if we can, and simplify or reduce the fraction. Okay, looking at this next problem, this will factor as x plus 6 times x minus 2. So we have to multiply this first fraction by x minus 2 in order to get a common denominator. Okay, minus x squared plus 3. All of that is over. I don't really need that there, but all that over is x squared plus 4x minus 12. And I'm going to erase this a little bit because I really don't need that. Okay. All right, multiply these again, FOIL it or use double distribution. 2x times x is 2x squared plus 3x minus 4x and minus 6 minus, remember this is in parentheses if we think about that, so I'm going to say minus x squared minus 3, and all of that is over x plus 6 times x minus 2. Okay. Factor, combine like terms first. 2x squared minus x squared is x squared. 3x minus 4x is negative x. And then minus 6 minus 3 is minus 9. All of that over x plus 6 times x minus 2. And it looks, we need to think of factors that would multiply to be negative 9, add to be negative x. Well, the only factors of 9 are 9 times 1 and 3 times 3, and none of those would combine to be negative x. So we cannot factor that numerator, and so my final answer stays just like that. All right, on the last one here, we have a number, 25. We have x squared y and y squared. So we need, on the first one, to multiply by 5y, so we can have a common denominator. Okay, and that's going to be 3 over 5x squared y multiplied by that. On the second fraction, The only thing we don't have in the denominator is the x squared, so we'll multiply by x squared over x squared times the 6x over 25y squared. So once we do that multiplication, we have 15y plus 6x cubed all of that over 25 x squared y squared. All right, we need to factor the numerator. We really can't do much with it, but we can factor out a greatest common factor, which is 3. And that'll leave me with 3 times 5y plus 2x cubed over 25 x squared y squared. Now, this is not a difference of cubes. It's not a sum of cubes. There's no way we can factor this anymore. And so all we could do is factor out the greatest common factor, but we go ahead and do that and then show the answer like this. And that ends notes for section 5.4. And